Dear friends, last time we already seen examples of limit based on this standard form. Limit some function tends to 0, special function exponential e raised to some function minus 1 over some function that is equal to 1. Today I would like to see example based on this standard form. A raised to some function minus 1 over some function that is equal to log A by G. Keep one thing in mind, A is not equal to 1. A is other than 1. Then and only then this exponential function is defined. Otherwise this function is not defined. So today let us see some based on that standard forms according to this one. Let us see. One of them example, limit x tends to 0, a raised to x minus b raised to x over x. That is equal to, we know that a raised to some function minus 1 over that some function, and that function tends to 0, then that comes out log a base e. So here limit x tends to 0, a raised to x, we need minus 1, so subtract it, minus b raised to x as it is, add 1 over x, that is equal to limit x tends to 0, a raised to x minus 1 over x minus b raised to x minus 1 over x. Agree? Yes. Now separate it term by term. Limit x tends to 0, a raised to x minus 1 over x minus limit x tends to 0, b raised to x minus 1 over x. Applying standard form, log a by z minus log b by z. So that comes out log a by b by z, log of a by b by z. We know that log x minus log y is equal to log x minus y. Let us see next one. Limit x tends to 0, a raised to x minus a raised to minus x over x. Now see, that is equal to limit x tends to 0, a raised to x minus 1 minus a raised to minus x plus 1 over x. Yes or no? Now separate it. Limit x tends to 0. Can I write here a raised to x minus 1 over x minus a raised to minus x plus minus 1 over x. Now one thing we have to see here. Here a raised to minus x is given. See, a raised to minus x. So a raised to some function over minus 1 over some function that we need. So in this limits here, a raised to x minus 1 over x. Can I write here plus a raised to minus x minus 1 over minus x? Yes, we can write it. Now we can separate term by term. Limit x tends to 0, a raised to x minus 1 over x plus limit a raised to minus x minus 1 over minus x, and minus x tends to 0. As x tends to 0, definitely minus x tends to also 0. That comes out log a by z plus this one also log a by z. So that is equal to log a square by z, or we can write that is equal to 2 log a by z also. Yes, very good. Let us see one more example is of this form. Limit x tends to 0, e raised to 3x minus e raised to 2x over x also. Here also we need limit x tends to 0, e raised to 3x minus 1 minus e raised to 2x plus 1 over x. Separate it. That is equal to limit x tends to 0, e raised to 3x minus 1 over, we need 3, over x minus e raised to 2x minus 1 over x. Clear? Now see, what we need here, e raised to 3x is there, so we need 3. So multiply and divide by 3. E raised to 2x is there, so we need 2. Multiply and divide by 2. Now 3 is constant, take it outside, limit e raised to 3x minus 1 over 3x. 3x tends to 0 minus 2 times limit 2x tends to 0 e raised to 2x minus 1 over 2x. So 3 into 1 minus 2 into 1, and that comes out 1. Clear? Now let us see. I would like to leave for you limit x tends to 0 e raised to bx minus e raised to ax over x. 0 less than a less than b, this condition is given. Second sum, limit x tends to 0 e raised to 3 raised to 2 plus x minus 9 over x. Now see, how we solve this one? That is equal to limit x tends to 0, 3 square into 3 raised to x minus 9 over x. This comes out 9, so take 9 common from numerator. Limit x tends to 0, 3 raised to x minus 1 over x. That is 9 into log 3 by e. In this way we can solve problem based on that pattern also. Now let us see left hand and right hand limit. Let us try to see this one. Limit x tends to a, magnitude of x minus a over x minus a. How to check it? Whether it exists or not. આ લક્ષનું અસ્તિત્વ છે કે કેમ? કઈ રીતે ચેક કરશું? See, we know that when we have to take left hand limit and right hand limit, if given function is in form of modulus form, in form of integral part function, મહત્તમ પૂર્ણાંક ભાગ વિધેય હોય, માનાંકીય વિધેય હોય, inequality હોય, અસમતા આપેલી હોય, or ઘાતાંકી વિધેયનો પાવર a raised to 1 by x હોય. The power of exponential function is 1 by x. Then and only then we have to take left hand limit, right hand limit. Otherwise we have to solve directly. Here it is magnitude, so we need to take left hand limit and right hand limit. Now see, right hand limit. So limit x tends to a plus magnitude of x minus a over x minus a. That is equal to limit x tends to a plus x minus a over x minus a. Why? Because x tends to a plus implies x greater than a, implies x minus a greater than 0, implies magnitude of x minus a is equal to x minus a. That is from the definition of modulus function. So that says that limit x tends to a plus 1, and that is 1. So right hand limit is 1. Let us say left hand limit. Limit x tends to a minus magnitude of x minus a over x minus a. That is equal to limit x tends to a minus, that is minus of x minus a over x minus a. Why? Because x tends to a minus implies x less than a, implies x minus a less than 0. This implies magnitude of x minus a is equal to minus of x minus a. Because we know that mod x is equal to minus x whenever x is less than 0. So once again that is equal to limit x tends to a minus minus 1. So that is equal to minus 1. Now see, left hand limit is 1. Sorry, right hand limit is 1. Left hand limit is minus 1. Both are exist, but they are not equal. So this limit does not exist. આ લક્ષનું અસ્તિત્વ નથી. In modulus sign we can solve in this way. Now see, limit x tends to 0 plus x over mod x. That is equal to what? Limit x tends to 0 plus x over x. Why? Because x greater than 0 implies mod x is equal to x. So that is equal to limit x tends to 0 plus 1, and that is 1. Now let us see limit x tends to 4 plus integer part function x. One-liner questions. X greater than 4, x tends to 4 plus means what? X greater than 4. So can I write here 4 less than x less than 5? Let us recall integer part function. This is equal to n. When? If n less than or equal to x less than n plus 1. These two are successive integers. આ બંને ક્રમિક પૂર્ણાંકો છે, n અને n plus 1. Clear? And other one is n minus 1 less than or equal to x less than, then this is equal to પૂર્ણાંક part function is equal to n minus 1. Integer part function, that is equal to n minus 1 only when n minus 1 less than or equal to x less than n. Less or equal to any one of them, that can be done. Here 4 less than x less than 5. So this integer part function is equal to 4. So here answer is 4. Now let us see limit x tends to minus 4 plus x. Minus 4 is equal to what? X tends to minus 4 plus implies x greater than minus 4. So minus 4 less than x less than, see here on real line 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5, likewise. Minus 4 less than x less than, here we have to take minus 3. So this is equal to, implies this integer part function x is equal to minus 4. So answer is 4, minus 4. Now let us see limit x tends to 4 minus fx is equal to what? So x tends to 4 minus means x is less than 4. So definitely here 3 less than x less than 4, because 3 and 4 should be successive integer. So that implies this mod x is equal to 3. So here answer is 3. Next one, limit x tends to minus 4 minus this part, that is equal to limit x tends to, that is equal to what? Only one liner answer, x tends to 4 minus means x less than minus 4. So definitely there should be which integer here? Minus 5. So this integral part x is equal to minus 5. So answer is here minus 5. Let us see slightly limit x tends to 4 plus integer part function of square root x. See here, that is equal to x tends to 4 plus, x tends to 4 plus x greater than 4. So 4 less than x less than something. I am not writing that part. Here we want square root of x. So here it should be 2, yes or no? Square root of 4 is 2. So definitely here we need to write 9. Then and only then it comes out root 3. So 2 and 3 are successive integer, n and n plus 1. So this implies integer part of square root x is equal to 2. So this answer is 2. In next form, let us see limit x tends to 4 minus 4, sorry, let us see, x tends to 4 minus this one, square root of x is equal to what? X tends to 4 minus x less than 4, so square root of square root of x less than 2, that should be 1, so 1 less than x less than this one. So what is integer part function here? Square root of x, that is equal to 1. So here answer is 1. Limit x tends to pi by 2 plus, let us see, integer part function x. Now x tends to pi by 2 plus implies x greater than pi by 2. So pi by 2 less than x less than something. Now 3.14 by 2, that comes out 1 point something, yes or no? So here comes out 2 less than this thing, 2 less than, nearest we have to see the positive integer. This comes out 3.14 over 2, that comes out 1 point something. So 2 less than x less than, there should be 3. So this integral part x is equal to 2. So what will be the answer here? 2. Now if I take limit x tends to pi by 2 minus of this one, so what happens? This implies x tends to pi by 2 minus x less than pi by 2, that is once again 2, that should be here 1. So what is this? Integer part x is equal to 1. So that comes out 1. Clear? Next let us see limit x tends to 8 plus cube root of x. Limit x tends to 8 plus cube root of x. Now x tends to 8 plus means x is greater than 8. That is 8 less than x. Here we need to take cube root of x. So here it comes out 2. So that should be a 27. Cube root of 27 is 3. So this integer part function comes out 2. So answer is 2. Limit x tends to 8 minus cube root of x. Let us see. X tends to 8 minus implies x less than 8. So cube root of x less than 2. So definitely there should be 1. So 1 less than x, this one. So this implies integer part of cube root of x is equal to 1. So answer is 1. In next form, let us see limit x tends to minus 8 plus cube root of x is equal to what? X tends to minus 8 plus x greater than minus 8. So minus 8 less than x. Here cube root of x. Here minus 2. Yes or no? So that should be minus 27. So minus 3. Yes or no? Sorry. See here minus 2. So that should be 1. Minus 1. That is this thing. Yes or no? So one real line, see, minus 1, minus 2. So minus 2 to 1 interval is that. So cube root of x is equal to minus 2. So here is answer is minus 2. Next one, let us see limit x tends to 8 minus minus cube root of x is equal to what? Limit x tends to minus 8 minus, sorry, x tends to 8 minus means x is less than minus 8. So here cube root of x less than minus 2. So here there should be minus 27. So you get minus 3 to minus 2, successive integers. So integer part of this cube root of x is equal to minus 3. So here answer is minus 3. In this way we can compute left hand limit and right hand limit also. Now inequality is given to us, then also we have to see left hand limit and right hand limit. Magnitude is given to, then also we have to see left hand limit and right hand limit. Let us see compute this limit. Limit x tends to 0, magnitude of 1 minus x plus magnitude of x whole magnitude of x. See, that is equal to limit x tends to 0 plus 1 minus x plus x. Why? X greater than 0 as x tends to 0 plus. So magnitude of x is equal to x. So that is equal to limit x tends to 0 plus magnitude of 1, and that is 1. So limit x tends to 0 plus 1. So that comes out 1 also. Magnitude of magnitude they can take this thing also. Next, let us see limit x tends to pi by 2 minus cos of pi by 2 into integer part function x minus x. Over x. Suppose that is equal to, I am writing here at cos pi by 2 or sin pi by 2 over x, this thing. Now we know that x tends to pi by 2 minus means x less than pi by 2, that is here 2, so that is here 1. So this integer part function is equal to 1. So that is equal to limit x tends to pi by 2 minus, here x minus pi by 2, sorry. So what you get? Sin pi by 2 minus x over x minus pi by 2. So that is equal to what? Limit x tends to pi by 2 minus, here you get cos x over x minus pi by 2. Take minus sign common from denominator quantity. Limit x tends to pi by 2, x minus pi by 2 tends to 0 minus. Can I write here sin pi by 2 minus x? Yes. Over pi by 2 minus x. Limit theta tends to 0, sin theta by theta. Right hand limit is also 1, left hand limit is also 1. So its answer is minus 1. So next, let us see limit f of x is equal to, let us see slightly some different way. F of x is equal to, given to us 2x plus 3, x is less than or equal to 0. 3 of x plus 1, x greater than 0, clear? Then we want limit x tends to 0, f of x is equal to what? And limit x tends to 1, f of x is equal to what? Now see, x tends to 0. Inequality is given, so we need to compute left hand limit and right hand limit. Limit x tends to 0 plus fx is equal to limit x tends to 0 plus, means x is greater than 0. So x is greater than 0, then x is greater than 0, then which part we have to take? Fx is equal to 3 of x plus 1. So that is equal to 3 outside, limit x tends to 0 plus x plus 1, that comes out 3 into 1, that is 3. So right hand limit is 3. So let us see left hand limit. limit x tends to 0 minus fx, limit x tends to 0 minus, limit x tends to 0 minus, x is less than 0. X less than 0 or equal to 0, then we have to take fx is equal to 2x plus 3. 2x plus 3. That is 2 into 0 plus 3 is equal to 3. So, this right hand limit as well as this limit, left hand limit exists and both have a same value 3. And therefore, this limit exists. Limit x tends to 0, f of x is also 3. Clear? In this way, inequality is given to us, we can find it. Next, our aim is to see limit x tends to 1, f of x. Now see, x tends to 1, we know that that is greater than 0. So, here there is no need to write left hand limit and right hand limit, because for inequality is given for 0, but not given for x. So, but whenever x tends to 1, at that time x is positive, so take f of x is equal to this value, 3 of x plus 1. So, limit x tends to 1, 3 is outside, limit x tends to 1, x plus 1, that is equal to 3 into 0 plus 1, that is equal to 3. Clear? Let us see more examples. Limit fx is equal to, given that x square minus 1 whenever x less than or equal to 1, minus x square minus 1 whenever x greater than 1. Then what we want? Then we want to check existence of limit x tends to 1 f of x. Clear? Now see, in this type of example, find out inequality is there, so we need to find right hand limit x greater than 1, x greater than 1, then what is value of fx? X greater than 1, then value of fx is minus x square minus 1, so that is equal to minus of 1 square minus 1, that comes out minus 2. And let us say left hand limit is equal to limit x tends to 1 minus x less than 1, x less than 1, then x square minus 1, so x square minus 1, 1 minus 1 is equal to 0. And therefore, you can see that here right hand limit exists, that is equal to minus 2, and left hand limit also exists, and that is equal to 0. So both are not equal. So limit x tends to 1 plus f of x is not equal to limit x tends to 1 minus f of x. And therefore, this limit f of x does not exist. Limit x tends to 0 f of x નું અસ્તિત્વ નથી, does not exist. Clear? Now, let us see this type of one more example. F of x is equal to mod x over x. X is not equal to 0, 0 whenever x is equal to 0. Then we want limit x tends to 0 f of x. See, here modulus sign is there. So once again we need to compute left hand limit and right hand limit. See here, limit x tends to 0 plus fx, limit x tends to 0 plus mod x over x is equal to limit x tends to 0 plus x over x. Why? Because x greater than 0 implies magnitude of x is equal to x. That is equal to limit x tends to 0 plus 1, that is 1. Right hand limit is 1. Now let us say left hand limit, and that is equal to limit x tends to 0 minus mod x over x. And that is equal to limit x tends to 0 minus x over x. Why? Because x less than 0 implies mod x is equal to minus x. So that is equal to limit x tends to 0 minus 1, that is equal to minus 1. And therefore, this right hand limit exists is equal to 1 and left hand limit is also exists, that is equal to minus 1. And therefore, they are not equal. Limit x tends to 0, f of x plus is not equal to limit x tends to 0 minus f of x. And therefore, this limit not exists. Limit x tends to 0, f of x does not exist. The next form I would like to leave for you, f of x is equal to x over magnitude of x not equal to 0 is equal to 0. Then check that limit x tends to 0, f of x exists or not. Clear? Next one. Let us see limit x tends to 5. Magnitude of x minus 5. Now see, modulus is there. See, x tends to 5. That is equal to limit x tends to 5, x minus 5. Why? No, x tends to 5 and 5 is greater than 0. This implies x is also greater than 0. This implies mod x is equal to x, and that is equal to 5 minus 5, that is 0. Agree with me? So this one is for you. Next, see, f of x is equal to, very interesting sum, a plus bx. A plus bx. X is less than 1. For x is equal to 1. B minus ax. X is greater than 1. And if only જો limit x tends to 1, f of x is equal to f of 1 is equal to f of 1. Then find value of a and b. તો a અને b ની કિંમત મેળવો. Now see, very interesting line in next page. See, here it is given that limit x tends to 1, f of x is equal to f of 1 given to us. That means this limit exists, that thing is given to us. So here right hand limit exists, left hand limit exists, and they are equal to f of 1. As this limit is given to us, this thing is given to us. આ આપેલી વસ્તુ છે, આ લક્ષનું અસ્તિત્વ છે, એટલે લેફ્ટ હેન્ડ એન્ડ રાઇટ હેન્ડ બોથ આર એક્ઝિસ્ટ. This implies limit x tends to 1 plus. Now see what is fx? X greater than 1, then x greater than 1, then b minus ax. So here what you have to write? B minus ax is equal to limit x tends to 1 minus fx. X less than 1. X less than 1, then what is f of x? A plus bx. So in place of fx, a plus bx is equal to f of 1. Fx is equal to 4 when x is equal to 1. So here it is given 4. Now this implies put the limit b minus a is equal to a plus b is equal to 4. So we have a formula, we have a two equation, a plus b is equal to 4 minus a plus b is equal to also 4. So if we add it, what we get? 2b is equal to 8. So b is equal to 4. 4, b is equal to 4, a plus b is equal to 4 is given to us. Put here, a plus 4 is equal to 4. So this comes out a is equal to 0. So our aim is to find out value of a and b. So a is 0 and b is 4. Whenever this limit equal to given to us, this limit exists means what? Right hand limit exists, left hand limit exists, and they are equal. And that is equal to given f of 1. So this one. Now according to given information, we can compute in this way, and we can find value also in this way. Next one. See here. If limit x tends to 1, f of x minus 2 over x square minus 1 is equal to pi, then find limit x tends to 1 f of x. जो आ तो अलग मेळवो. Clear? Very interesting question. Here it is given that limit x tends to 1, f of x minus 2 over x square minus 1 is equal to pi. So can I write that is equal to this limit exists, that thing is given to us. So separate it, this limit as per that form x square minus 1 is equal to pi. Put here bracket, put here bracket. This implies this limit is equal to pi into limit x tends to 1 x square minus 1. So this implies limit x tends to 1 f of x minus 2 is equal to pi into 1 minus 1. So here we can separate limit term by term also. Limit x tends to 1 fx minus limit x tends to 1 2 is equal to 0. And limit of constant term is constant. So this implies limit x tends to 1 f of x minus 2. Why? Because this limit constant, limit of constant term is constant, and that is equal to 0 is given. So this says that limit x tends to 1 f of x is equal to 2. This is the answer. Next one. Now let us see, in general questions are there for limit. Suppose we wish to find limit x tends to a, limit x tends to a sine of magnitude of x minus a over x minus a with right hand limit. Let us see what happens. Now x tends to a plus x greater than a, so this magnitude is equal to x minus a. So what we get? Sin x minus a over x minus a, and limit x minus a tends to 0 plus, so that is equal to 1. So this limit comes out 1. Yes or no? Yes. Now suppose we wish to find limit x tends to 0 plus integer part function x plus integer part function of minus x is equal to what? Very easy. See, x tends to 0 plus this integer part x plus integer part minus x is equal to, we want x tends to 0 plus implies x greater than 0. This implies 0 less than x less than 1. This implies this integer part function x is equal to 0. Now see here, x tends to 0 plus implies x greater than 0, implies minus x less than 0, implies minus 1 less than minus x less than 0. So this integral part of minus x comes out minus 1. So what you get? 0 minus 1, answer is minus 1. They can give the combination also, they can give product also, they can give division also. But if we have a proper knowledge of modulus function as well as integer part function, પૂર્ણાંક ભાગ વિધેય અને માનાંકની વ્યાખ્યા આપણને ખબર હોય તો આ ટાઈપનો કોઈ પણ સમ આપણને આપે તો આપણે આરામથી ઇઝીલીથી કરી શકીએ. હવે હું તમને થોડાક ઇન જનરલ ક્વેશ્ચન્સ આપણે જોઈએ. તમને ઇઝીલી ખબર પડી ગઈ હાઉ ટુ કોમ્પ્યુટ લેફ્ટ હેન્ડ લિમિટ એન્ડ રાઇટ હેન્ડ લિમિટ. નાઉ લેટ અસ સી લિમિટ x tends to 0 cos ax minus cos bx upon cos cx minus cos dx. How to find this limit? See here, that is equal to limit x tends to 0, cos minus cos is given, so minus 2ss. Apply this standard form here. So minus 2 sin a plus b by 2 into x sin a minus b by 2 into x over what we need? Minus 2 sin c plus d by 2 into x sin c minus d by 2 into x. Agree? Minus 2 get cancelled. Limit x tends to 0. What we need? Sin a plus b by 2x over, we need a plus b by 2x, so multiplied and divide by. Clear? Next what we want? Next, sin a minus b by 2x over what we need? We need a minus b by 2x, so multiplied and divide by. In denominator quantity what we need? Same way, sin c plus d by 2x over we need c plus d by 2x into c plus d by 2x into what we need? Sin c minus d by 2x over c minus d by 2x into c minus d by 2x. Yes or no? Now see, a plus b by 2x, a minus b by 2x. So that is a square minus b square by 4. In same way in denominator quantity, c plus d by 2x, c minus d by 2. This ax is taken common from numerator, x taken from a numerator as well as taken from one common from denominator quantity and cancel it. So here you get c square minus d square by 4. then into this limit comes out 1, and in this limit also comes out 1. In denominator quantity, this limit comes out 1, as well as this limit comes out 1. So what is the answer? A square minus b square over c square minus d square. See, these are the some examples of limit. Now see how to take a combination of algebraic function. I am taking very simple example. X tends to a, x sin a minus a sin x, or let us see, x sin x minus a sin a over x minus a. So how to solve this type of question? Very interesting. See, x sin x minus a sin a. All these four parts are different. Algebraic function, trigonometric function, of course constant, and here constant sin a. 1, 2, 3 and 4. This type of functions are given to us. In that case, see, x sin x is there. If there is a x sin a, then we can take x common, so sin x minus sin a, and we can simplify it. Yes or no? Yeah. So second and third, product of first and last, product of first and last, or product of second and third, subtract and add. This is the procedure. So that is equal to limit x tends to a, x sin a minus x sin a plus x sin a, last term as it is, minus a sin a over x minus a. Clear? So that is equal to limit x tends to a, take x common, what you get? Sin x minus sin a over x minus a, plus sin a common, so x minus a over x minus a into sin a. That is equal to limit x tends to a, x, s minus s, that comes out to cs, 2 cos x plus a by 2 sin x minus a by 2 over x minus a plus sin a, because x minus get cancelled. Now see here. Now sin theta is there, sin some function is there. Over we need some function tends to 0. Over x minus a is there, take 2 here. So what we get? Limit, let us write here, sin x minus a by 2 over x minus a by 2, x minus a by 2 tends to 0. So this part is taken. Remaining x and this one, give limit to that form, limit x tends to 0, x cos a by 2, plus sin a, give limit to that part also, or you can write directly also sin a, because it is a constant term, and limit of constant term is constant. So that is equal to what? Put the limit, a cos a, see, x tends to a, x a plus a by 2, that is a, and this is into 1, plus this one is sin a. So answer is a cos a plus sin a. I would like to leave this sum for you. Limit x tends to a, x cos x minus a cos a over x minus a. Answer is minus a sin a plus cos A. Limit x tends to A, x tan x minus A tan A over x minus A sec square A plus tan A. Clear? Next one. Limit x tends to A, x cot x minus A cot A over x minus A is equal to minus A cosec square A plus cot A. Limit x tends to A, x sec x minus A sec A over x minus A is equal to A sec A tan A plus sec A. Limit x tends to 0, x cosec x minus A cosec A over x minus A cosec A cot A plus cosec A. I am leaving this one for you. In next lecture, if you are not able to solve it, then we are going to see that thing. If you are not able to this one, then inform me. Then I am going to solve this type of sum. Clear? Almost this complete the preliminary limit concept.